Good afternoon, everyone. I welcome all the participants to this session. And we have with us Mr. Partha Majumdar. He is our alumni and he has been gracious enough to contribute to this knowledge sharing session for our alumni and our active learners. So Partha is one of the most active alumni and he has more than 20 years of experience and he has provided many software solutions. He has worked on many enterprise software solutions to the ministries, to the Government of India, Kingdom of Saudi Arabia, and other countries as well. So Partha will be taking this session on uh, data science. This is for the beginners, and I would request all the participants to take the full benefit and ask your queries in the question and answer in the Q&A. So you have a Q&A button on your right side of your screen, so you can put your queries over there. Intermittently, Partha will be addressing to your queries, and I hope you all are going to learn and enjoy from this session. So over to you, Partha, now, and I am signing off now.
Good morning, everyone. Just 1 minute, I will open the Q&A session. Yeah. Okay. Let's start the session. This is going to be a little bit long session, so I will get started straight away without any ado. So we will discuss about data sciences. Now, data sciences, as you all know, most probably most of you are aware of, is a very vast area, and so we will try to discuss as much as possible in this 1 hour session, and my effort will be to try to introduce you to a lot of terms and terminologies which you can explore further. So that is the basic intent. It will not be possible for me in a 1 hour session to go deep into any subject. However, I will try and see how best I can introduce this matter to you, and I hope it will be useful to you. So basically, this session I had designed with business people as well as technical people in mind. And typically, the business people or the technical people would be some kind of decision makers. The decision makers need not always be a CXO. Decision maker also can be a manager or even a programmer can be a decision maker. Basically, because you have to choose between what solutions to work on, what's the technology to utilize, and which is the best algorithm to utilize, and what are the best models to utilize, etc. So there are decision makers all over enterprise, and so this session possibly can help people of a large array of backgrounds to take care of. Now, typically in IMT, we have people who are studying to be managers or who are studying management. So I hope this session will be useful in terms of introducing the various aspects which is available in data sciences, so that you can make very good management decisions when it comes to selecting technologies or selecting solutions and selecting teams to do the work, etc. So now, like I discussed already, we will try to look at, this is going to be very difficult for me, but we will try to look at the whole data science story from a business perspective as well as from a technical perspective. Now, we do not have a facility where you could interact with me except for via Q&A, and I will do my best to look up the Q&A once in a while and try to answer your questions as and when we are getting the questions. Now, like I told you, I will try to introduce as many topics as possible for me in this 1 hour, and I will request you to kindly note down the key terms which I will try to emphasize, and those key terms are something which you can dig deeper, and that will enhance your knowledge of data sciences and also enable you to take advantage of this session in terms of learning more about it and applying it in your practical field of your organizations or in your businesses or in your student life, wherever it is applicable. Okay, now we get down to the core of the session now. So we will start with a few examples. Now, examples, if you ask me, if you open the internet and say examples of data sciences, you will get numerous examples. There are so many examples in the world available today that you can get numerous of them. So I will not go into those examples. Instead, what I will do is that I will discuss with you some examples where I have actually worked or I am actually working. And these are either ready solutions already implemented somewhere, or there were some concepts which we have discussed and it did not take full shape at that point of time. So these are the kind of examples which I will discuss with you. This should give you an idea regarding where are the possibilities of applying data sciences. I will try to be as diverse as possible in terms of application across industries, etc., so that it will give you an idea regarding where exactly these data sciences can be applied and where exactly the industry is applying these data sciences as on today. So we start with the first example. Now this is a solution which we have implemented. Now this was a problem given to us by a gym chain in Brazil. Now what this gym chain had a problem was that the gym chain used to distribute or used to sell packages. So the packages would typically be, you can lose 5 kilos in 6 months, or you can lose 10 kilos in 9 months, or you can reduce your tummy by 1 centimeter in 3 months. So these are the kind of packages. Now, once the packages were sold to the customers, many of them, maybe they would achieve the results what they had joined the gym for, or there were many who would be disgruntled that they joined the gym but they did not achieve the results. So the gym had a problem that they were coming up with a lot of customers who were disgruntled that they were not able to meet the goals, what was their purpose of joining the gym. So the gym wanted a predictability that if I am offering a package to a customer, the customer has a maximum likelihood that he will achieve the goal what he has joined the gym for. So this was the problem. Now what we did was that we took the problem by its head and we told the gym, okay, tell us, what are the packages you offer to the customers? We took all the packages what the gym offered to the customers and we classified the packages into various categories. Now these categories became, okay, fine, if for certain this kind of people we can offer this category of packages, or for this kind of people we can offer the category B of packages. So we classified them accordingly. Now you would know that in modern day gyms there are a lot of equipments, lots and lots of equipments, and each equipment produces huge amount of data. Every time the equipment is utilized, it produces huge amount of data. So what we did was that we collected the data, elements what is possible to collect from each equipment, and we created a schema on which we flattened the entire data so that for a particular user utilization of the equipment by a user, I could get one data which could be utilized as a reference point of that particular instance of usage or whatever be the criteria. Apart from that, we get some data regarding every individual as well. For example, the person has a height, he has a weight, he has a body mass index, and so many other parameters. So this data also gets collected. So we got the data what we wanted to collect from the equipments and from the person, and we took the categories of the packages which we could offer to them. Now this became a classification problem. Now the classification problem was based on the input of the data which we would get from the equipments and from the people. We would try to predict which package to give to this person for the best result. Now what is the classification problem we will discuss slightly later, but you nevertheless note the term classification problem. This is a very important thing in data sciences. So what we did was that when we collected the information from the different equipments, you believe me, there were more than 35,000 parameters for which we got information. Now we first of all took the parameters and we found out from the existing data which we had in with the gym that which of the parameters were very highly. We had to do some amount of data cleaning. Of course, all the time all the data doesn't come in, so we had to do data cleaning. After cleaning the data, we took the parameters and found out which parameters are very highly correlated to each other. Now, because you understand if people with slight amount of statistical background will appreciate that if I have data which is very highly correlated, they will lead to the same kind of a result, and that will diminish the quality of the prediction what I will be making. So we removed the essential non-essential parameters, and then we applied something known as a principal component analysis, another term which I'm coining right now. principal component analysis. Principal component analysis we basically do so that we come out with the parameters which has got the maximum impact on giving me a prediction or in terms of solving the problem. So I will apply principal component analysis to find out the parameters which has the maximum likelihood of providing me or guiding me towards the final solution what I'm looking to do. After doing that, we applied a prediction model which is known as SVM, support vector machines. The support vector machines can be utilized for classification that problems, and we applied that. So after having applied support vector machine, we created the model which could be utilized. Now the next question is how did we apply the model? Now the model was ready, and so when a new person walked into the gym would tell that person, okay, fine, you go to equipment number X, Y, and Z and perform certain tests or certain usage of the equipment. When you use the equipment or when she used the equipment for some amount of time, the data was collected. Then the gym would collect the personal information regarding the person. Okay, fine, there were certain things like height, weight, body mass index, and there were some habits like how many times they eat or how much quantity they eat per day, etc. There were various parameters on which this data was collected. Then this input was put to the model, and when this input was applied to the model could tell us, okay, you please prescribe packet number X to this person because that has got the maximum likelihood that this person will be able to achieve that result. You believe me, we observed this system and we collected the results of the system for over a period of 3 years, and we found that the accuracy of the system was nearly 92%. That is not a bad accuracy for a system of this nature. So it was a reasonably successful project. So this is one application of data science where we utilize predictive analytics and applied it for classification problem. Okay, now we move to the next. I will just check the Q&A if there's anything there. There's somebody who writes, I have 11 years experience in production in aluminum smelters. The profile is BTech and from distance, and I am present job and want to change the fields and enter data science. Please suggest how to transfer from zero to program. Okay, that's what we're discussing today. So essentially we can carry on because that is what we are discussing. This person is not giving the name, so I cannot know that. Okay, now we move to the next example. The next example is from the telecom sector. Now in telecom sector, there is a very popular business known as the interconnection business. Many of you may know this. I'm not so sure how many of all the participants know this. So I will briefly explain what is interconnection business. Now, the simplest way to understand interconnection business is to understand the example of how you make international calls. Supposing a person is making a call from New Delhi to, let's say, New York. Now, this person will most probably have a mobile phone or a fixed phone, that doesn't matter. So let's say, for example, the person has a mobile phone from Airtel, and he is in New Delhi. So when he makes the call to New York to his cousin or his friend or whoever in New York, Airtel will take the call, and Airtel will be able to take the call only as far as New Delhi, because beyond that, Airtel may not be able to carry the call. So what Airtel will do is that Airtel will hand over the call to most probably BSNL. BSNL will take the call and carry the call up to the borders of India before it hands over the call to most probably Pakistan Telecom. Then Pakistan Telecom will take this call, hand over the call to maybe Iran Telecom. And from Iran Telecom, the call will be handed over maybe to Turkey Telecom. And like this, the call will traverse network to network. It will keep on hopping till it reaches New York. If you make an international call, you'll notice that before the call gets connected, you get some beeps, beep, 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 beep. That's basically, it is hopping from network to network. That's what is happening. So ultimately, the call reaches New York and you talk to this person. Now, the basic thing what has happened is that there have been many telecom companies which have been involved in terms of carrying this call from New Delhi to New York. So each of the telecom companies will ask for their money. I carried the call for you, so please pay me this money. So this money, what they collect, is basically known as this is the interconnection business. This is the interconnect fee what the telecom operators collect from other telecom operators who assist you in making international calls. Now this is a huge business. This is a huge business. Even a smallest of telecom company makes about 120 to 150,000 US dollars per month from one partner. And typically a telecom company would have around about 40 to 50 partners. So you can imagine the amount of money which comes from this business. Now, what is happening is that when the telecom company who is sending the call, he is lining up all the other telecom companies to carry the call. What he is basically doing is he's setting up a route. He's setting up a route for you. On that route, the call will be traversing. Now, what the telecom company has to do is that he has to ensure that the route what he takes to take the call across from the origin to the destination has the least cost. If the cost of carrying the call from the source to the destination is the least, then the telecom company makes the maximum profit from that particular call. There can be other parameters also. For example, a person says, I want that my call is of premium quality. I want the best quality, call quality. So the telecom company will say, okay, fine, I will get you the route which has got the, which will provide the best quality of conversation while you are on the call. So now I have to find the route which has got the least cost and provide the best quality or the quality as desired by the customer. So this is the problem which telecom companies have, which is known as the least cost routing problem. So he has to compute the least cost and the suitable quality and make the maximum profit from it. For making the least cost routing, the telecom companies have something known as a routing table. Now, based on the routing table, they will select which route to take and they will carry the call. This is the area where data sciences can be applied very heavily. Now, how to calculate the least cost routing is basically, if I try to make the prediction based on historic data that as on so and so date in the past, I carried this call with this particular quality and at this particular cost, it made the best sense. It can help me in making decision regarding a current call which I am trying to carry. So we can apply data sciences here, and we typically use something known as recurrent neural networks to compute these compute these least cost routes dynamically so that it produces the maximum benefit for the callers. So I hope you got a sense of what data science application is in terms of one particular aspect of telecom business. I will again have a check on if any questions are there. No questions, so we can carry on to the third example. Third example is an example from insurance sector. Now we were given a problem by an insurance company which said that we are having massive revenue loss, basically because about 60% of the claims are fraudulent claims, and we are paying out the money, and these are basically fraudulent claims because of which we are losing a lot of money. So this was the problem which we had to solve. So how did we approach this? Now what happens is that during the insurance claim process, there are number of documents which have to be submitted. Now these documents are typically text matters, and the text in any document can be analyzed. So we used a system called IBM System T. Now IBM System T is a system which has been developed by IBM for the purpose of text analysis, the field is known as text analytics. So for text analytics, we used IBM System T. Now IBM System T has got a language. People who are familiar with databases will know that there is a language known as SQL, Structured Query Language. Now IBM System T also has a language like this, which is known as AQL, Annotation Query Language. Now in Annotation Query Language, what we do is that we go through, we gathered all the historic claims documents, and the historic claims document, the insurance company classified that these claims documents are fraudulent and these are genuine. So based on that intelligence, what we got from the historic data, we found out what are the patterns in the fraudulent documents and what are the patterns in the genuine documents. And these patterns, we programmed it using AQL, Annotation Query Language, and fed into the system. So now what is going to happen is that when a new claim came in, these claims will be processed through the rules which we had, through this AQLs what we had written, and the AQL could determine whether this is likely to be a fraud case or this is likely to be a genuine case. So this is another application of data sciences. Okay, we've been talking lots. Next, what I will try to do is that I will take you on a short break where I will show you an example in action of a data product which can solve a problem. So we can do something known as emotion analysis. I will show you a tool which can do it, and I hope you will get a short break from so much amount of talking that I'm doing. Now the thing is that I have taken tweets which is available from Twitter, and the tweets which I gather from Twitter, I am able to analyze what is the main emotion that is being what do you call depicted from those tweets. So let's see this in action to understand application of data science. So I will go over to Chrome and I will invoke this tool. You can also, I will put this tool link on the chat so that you can try it yourself also. There's a question how to apply data science in retail sector. Okay, I believe we will be discussing that. Just hold on for a moment. We will see how to apply that. I will definitely take this question for later also. Another question is learning computer programming essential for data science? I believe it's absolutely necessary. You cannot escape learning computers programming and apply data sciences, but there is also a possibility that there are a lot of products which is available, so you can become a consumer of a product of data science and utilize it. I will give you example. For example, we will discuss a product called Amazon Deep Lens, which can be applied for data sciences, and we will discuss that Deep Lens in a little bit more details. Another question is in which position data science uses. I do not understand this question, so I'm not trying to answer this question. Okay, now let's get back to the example. So this is the tool which will do emotion analysis. Now let's say I search for some tweets. I do not want to be. Let's say I search for coronavirus. So I say fetch me about 4,000 tweets on coronavirus. 1 minute. So it is fetching me tweets for coronavirus. It takes a little bit of a time. So while we are waiting for that, okay. So now you can see that the tweets on coronavirus have been fetched. So first of all, one of the applications of data science is to be able to visualize the data. So you can see that this is a time series. This is the way people have been tweeting about coronavirus in the recent past. Now coming to the main topic of emotion analysis. So you can see that we have fetched the tweets from coronavirus, and the tweets have come from these parts of the country right now. Basically the tweets are coming from India right now. And the emotion, what we get from these tweets is that anger. People are feeling angry about coronavirus. So you can see that I'm able to detect emotions from the tweets, what I'm able to fetch. So I hope I gave you an example of a practical example of application of data science, and you could see it in action. So we have no further questions, so we will continue. Okay. I take one last example. This is a problem from the HR sector. HR people have a typical problem where they, which is known as the renege problem. Renege basically means that the company makes an offer to a candidate after going through all the process of what do you call all the process of selecting the candidate, interviewing and all this kind of stuff, and makes the offer, and the candidate accepts the offer and then does not join up. So now this is a very typical problem for HR people, because this means that they have to spend a lot of money in terms of having people who will interview, money and time both. Interview, then they will have to pay the the companies which get them the candidates, and then the candidate they've made letters, offers, they have to be sent by post. The post also costs money, and all these things happens, and ultimately the candidate says, I am not joining. So the company, through data science, we are able to predict whether a candidate who has been made an offer, whether he will join or not. Based on that prediction, we are able to decide whether to carry on further with that candidate or not. If we, the chances of that, if we take if these predictions are good, then the amount of money we will waste in terms of pursuing candidates who will not join will reduce. So that is a huge advantage for the HR departments of any company, and through Reneg analysis, it is possible for any company to save a large amount of money. Okay, now while we are discussing the problems and applications of data sciences, I will take the question on retail industry. Retail industry, you can see number of applications of data sciences. If you just open up any site like Flipkart or Amazon. Now, one of the basic applications of data sciences in any of these applications is that you will find that they provide a recommendation system. Recommendation system basically says that when you open up Amazon, for example, or Flipkart, they will tell you, oh, you purchased this product, then I believe you should purchase this product also, because people like you who have purchased this product also felt this was a useful product for them. Recommendation system is a very typical application of data sciences. Then, of course, there are other applications like any other industry, like based on the sales, what is happening through a retail chain. They can predict, as of if it is in the month of winter, will this product sell in what quantity. That is typically what data sciences is able to predict and help the retail industry in terms of making a suitable amount of procurement so that they buy the right products to sell and their sales is the maximum. So these are typical examples where retail industry is able to apply data sciences. I hope this answers your question, and we move on to the next aspect. Oh, we have one last example. The data sciences is not only applicable in industries, it is also applicable in personal lives. So a typical example is that a diabetes patient may require to understand how much insulin the person has to intake so that the body is stable. Now, I actually solved this problem. My wife is diabetic and she has to take insulin, and I studied her insulin intake over a period of time and then created a model by which I could tell, okay, fine, take this much amount of insulin so that your next day is peaceful. Now, typically you understand that if the level of insulin taken is not appropriate, then the person can have a low sugar case or a high sugar case, and both of which can be dangerous for the person and can cause discomfort. So data science can be applied to such problems also, and this provides a reasonable amount of comfort to the people who are using these solutions. I will just check whether we have any further questions. No question. How can we apply? Okay, no questions. So we move further. Okay, now that we have gone through the examples, we come to how do we solve such problems and what are the avenues available or tools available with us with which we can solve the problems using data sciences. Now, first of all, we should understand that one of the main areas of data science, area which started very early in data science, is that area of data analysis. So first, the moment we had data in this world, people started analyzing. Various statistical methods are available. Various statistical methods were developed, and people used to do analysis. Now, as the amount of data started growing, people realized that we require computers, because that is no longer possible to process those data using any other device which is available, and we required computers. So computers came into being, and one of the primary purposes why computers were invented was to be able to analyze data. Now, when in the initial stages, at least when I started my career in 1989, the primary way we used to do data analysis was by taking the data from the OLTP systems. OLTP stands for Online Transaction Processing. So we used to take the data from online transaction processing system. This system could be for anything. It could be for tea garden automation. It could be for hospital management. It could be for travel and tour management, etc. We used to take the data from the OLTP system, and we used to generate what is typically known as the MIS reports and the DSS reports. MIS stands for Management Information System Reports, and DSS stands for Decision Support Systems. Decision Support Systems reports. Now, through these reports, the managements used to make decisions, and they used to carry out the businesses in the most optimal manner. Now, as the volumes of the data started increasing, it was seen that it is no longer possible that OLTP system can be only relied upon to provide MIS and DSS. So a new kind of system came into existence, which is known as OLAP. OLAP stands for Online Analytics Processing Systems. So OLAP systems, what we did was that we took the OLTP data, applied something known as ETLs. ETL stands for Extract, Transform, and Load. So we applied ETLs and transformed the data from structured tables or the relational tables to something known as data cubes. Now, data cubes all of a sudden provided the same OLTP data from multiple dimensions. And now it is possible to view the same data which is available in OLTP systems from multiple dimensions, and that made possible lot of other analysis of the data. To give you an example, in a telecom operator's enterprise, we will typically have about 50 to 60 systems to manage the telecom operators' routines. Now, when we take the OLTP data from 50 to 60 systems and put it into a data warehouse using ETLs and create the data cubes, you can imagine the number of dimensions in which I can view the data and the number of analysis we can do. So now all of a sudden I'm able to see the customer data versus the billing data and see whether I can find relations, whether I can find any kind of linkage, and I can make analysis based on that. This has got further. Now we have much more amount of data. So we have come to data sciences where we apply, which we will discuss slightly later. Now, one of the main areas where we are applying data analysis today in the world is in social network analysis. We are all of you, I'm sure most of the participants here are using social networks, and we all understand that social networks produce a huge amount of data. So when we have such a huge amount of data, we are able to make huge amount of analysis. Popular social networks are Twitter, Facebook, newspapers, magazines, etc. Twitter has around about 5 billion users. Facebook has around about 1.5 million active users at any point of the time of the day. So you can imagine how much amount of data is collected. Now this data, when analyzed, can provide useful information for making marketing campaigns. Our psephologists can make election analysis, or medical people can make analysis regarding what to do in a medical emergency, etc. I will give you an example. Now look at this. This is the social network of my Facebook account. This is no longer possible. You will not be able to create these charts any further, basically because it has been around about 6 years that Facebook has stopped sharing its data with the public. So it was possible earlier. So when it was possible, I had captured my data, and at that point of time, I created my social network of my Facebook friends. You see in this diagram, in this chart, that there are clusters. So these clusters are basically the different clusters of friends that I have. Maybe they were in my school, or maybe they were in some office of mine, and they were all connected. Now, how I can use this visualization is that if I want to send, let's say, a message to my school friends, so I can find out from the network at which point I should share the message so that it reaches maximum of my school friends. So this is possible from such analysis. And these are typical. Let's say I want to do a marketing campaign, or I want to do an awareness campaign among my office colleagues that they should join courses from IMT. So at which point in the social network I should introduce my advertisement or my message so that it reaches maximum number of people within my target network. This was possible. See another visualization. This is my LinkedIn network. You you can still create your LinkedIn networks because LinkedIn data is still shared with public. And you can see that here again, we get a similar visualization. Now, these visualizations I created using the tool called Gelfi. So Gelfi is a very powerful tool. You can check it out and you can see how you can create various networks using Gelfi. Now, if the people who are interested in programming, you can go to my blog. I have given the complete process how you can create the LinkedIn network visualization, the techniques and the codes and how to collect data. Everything is provided there. So I will now quickly check back whether there's any question on the channel. No questions. No, we have some questions. Any examples of company applying data sciences in energy industry, oil and gas? Definitely there must be, but I am not very aware of these such examples because this is an area which is not very familiar with me. Now, is there any system to know which is fraud and which is in? I just discussed an example of that from the insurance sector. How can we apply data science in retail? Is real estate. Real estate has a lot of applications. Real estate has a lot of applications like with the real estate sector, they use data sciences to predict whether what will be the most optimum cost at which they can they can construct a house, or even before that, what is the most optimum price at which they can buy a property on which they will develop. So there are a lot of applications for real estate sectors for data sciences. Can stock market prediction? Yes, of course. Stock market predictions can be made using data sciences. In fact, I have developed a tool which predicts the stock market and I am reasonably benefiting from it. This particular tool which I have developed using data sciences for stock market prediction predicts at around about 80 to 85% accuracy rate. So that is this question answered. There's one software called Power BI. Can Power BI carry out data? Power BI is a software which can be utilized for the purpose of data visualization. So Power BI definitely can be utilized for data visualization. And when you're able to visualize data, you can make analysis. And it is not a software which can be used for predictions, etc. So that is just like Power BI. There's another tool called Tableau. You can use Tableau also for the purpose of data visualization. How big data is different from big data is another form of data sciences. I believe they are the same, and there is not much difference except for the fact that in big data we're talking about huge quantities of data, and there are when the quantity of data increases, there are techniques which we have to apply before the data can become useful, or they can become in the form in which it can be utilized for the purpose of making analysis. I'm a product owner manager with about 6 years of experience in providing tech solutions for business perspective. What can be the best provider to look for it? Oh, I do not know. What do you call? I'm just discussing everything so you can find out which suits you and apply it to yourself. Okay, we will come back to our presentation and move ahead. Another area of data analysis is network simulation. Now, this is a software which I'm showing you, which I created using a tool called NetLogo. Now, take for example, a practical example of applying network simulation in this COVID era. We know that one of the ways to control COVID coronavirus is to do social contact tracing. So contact tracing, if I create a network of a person and who is maybe infected, if I create a network of that person, if I'm able to get his network from various sources like Facebook or Twitter or anything like that, or other mechanisms, and then using on his network, I find out, I make some simulations on that network of his and find out where all this person can have or who all can have been infected by this person, and how much time it will take by this person to infect how many number of people. This is a typical example of a network simulation. So you can create such models using data sciences There are various tools for it. One of the tools I'm displaying to you, that is known as net logo. So the thing is that you can plant the network of any network, and then you can apply various parameters on which that you want to see the simulation of the network, how it will spread and how much it will spread, where it will spread, and then you can study the various statistics based on those parameters. Okay, now we come to the next aspect, which we have been talking about quite a lot, that is predictive analytics. This is a huge area of data science, and one of the main applications of data science is that I need to be able to predict what will happen in the future. So this is a huge area. Now, there's some examples we have been discussing as we have been talking all over the period of time, like how much a price of a house can be in a given locality. If I could predict that, it will help me in negotiating the price of a house in that particular locality, or how much revenue I will be able to earn from my shop or from my retail store chain in a given season. If I could predict that, and this is possible, it is possible to do that using data sciences or predictive analytics. Or what would be the outcome of an election? You know that we do this all the time, and you have been watching a lot of elections in India or USA or any other country, and this is a huge area where data science is applied. So just by taking a sample of around about 1,000 or 2,000 people, I'm able to predict whether Joe Biden will win the elections or Donald Trump will win the elections. So it is possible using data sciences. I will show you one specific example now of something you have been using very often. Most of you, I'm sure all of you use a mobile phone, and using mobile phone, all of you are either using WhatsApp or earlier you used to send SMS. Now, when you're typing SMS, the mobile phone gives you what can be the possible next letter or next word that you want to type. So this is known as the next word predictor. So this is an example of a next word predictor. You can see this, it's a simulation of that. So just go through this example. So now if I type a text, you can see that it is able to predict what can be the possible next word that you want to utilize. So this is the application of data and predictive analytics. So I will take a short break from my talkings while you are viewing this tool. Okay, now let me tell you how I developed this tool. What I did was that I took data from Twitter, a lot of data from Twitter, and created something known as n-grams. N-grams are basically combination of words. So I created, let's say, 2 grams. 2 grams basically with all combinations of 2 words in the data that I collected from Twitter. Like that I made 3 grams, 4 grams, 5 grams, up to 8 grams. Then on that n-grams, I created a statistical model. So when a person is typing some text, it is able to go through all the n-grams and find out which n-gram has the maximum possibility of being being able to provide the next word. So now this is the you've seen it in action. This is the way your SMS suggester or the WhatsApp suggester basically works. Now you understand that when I created my model is restricted to the fact that it only understands the sentences what I fed him from Twitter. So its vocabulary or its ability to generate the next word is restricted to the amount of data what I have put in. Typically, you can understand a term which is known as corpus. Corpus basically is the amount of text which I have fed into the system, based on which I am creating my model. So based on the corpus, its knowledge is restricted to the corpus. Now, if I increase the corpus, it will obviously have more knowledge and be able to work much better. Again, if someone is interested in finding out how to develop this or how to utilize this, I have given you the link. You can check that and you can find it on my blog. In fact, you can go to my blog and say next word predictor in the search and you will get it. Okay. I will just have let's finish this and then go and check the question answers. Now, what is there are so many people asking where do I apply it, where do I apply data science, where do I apply predictive analytics. Now how it works is that you need to find out in your operations what exactly you want to predict. You just ask this question to yourself and then find out what data can be utilized to make the predictions, and you can create a model. That is the way it works. Just look for problems which you want to solve, and it can be solved using data sciences. It is as simple as that. Okay, so I will just check the questions once again. Are we going to study any paid tool software which make market research? No, we're not studying any tool. We're not studying any tool. How to analyze fraudulent data. Yeah, there are various techniques, and here again I will just be discussing something known as the various techniques of machine learning, so you can apply them to find out what is the fraudulent data. I will discuss a specific. Okay, let's discuss a specific case for one kind of fraudulent data. You understand that all of us use mails, and in mails we have something known as a junk folder where the spam mails get collected. In one way, the spam mails are basically fraudulent data. So this is a typical example of data sciences, which we can basically classify this as machine learning, because what I'm doing is that I am providing the software is basically trying to able to analyze and find out whether an incoming mail is a spam or not. So how this is done, I will discuss it slightly later, and we will. But this is a typical example of how to apply it for fraudulent data analysis. Okay, let's move forward as there were no more questions. So now we come to the next paradigm, which is the machine learning. So like I was discussing, one problem of machine learning, that is spam detection. Now machine learning is very different from traditional programming, basically because of how machine learning programs are written. Now what happens in traditional programs is that I have my data, I take my data and I take my rules and I apply my rules on the data to get an output. Take for example, I have to calculate the salary in the payroll system. So I will give my data. My data will basically contain figures like this fellow's basic is so much, his HRA is so much, etc., etc. All this is data. Now I will have my rules. I will say my rule for calculating the monthly salary is basic plus HRA plus transport allowance minus income tax. Maybe that is the formula. And so this is my rule. So I will apply this rule on the data to calculate the salary to be dispersed to every person. So this is the way traditional programming works. Machine learning is a totally different way. Here what I do is that I take my data and I take my output and I tell that this is my data, this is my output. Now you tell me what is the rule which I have to apply so that I can use when I give a new data, I will get the output. Now take for example in the case of spam detection. What I will do is that I will take lot of mails which are my data and I will give him the output, that is this mail is fraud, this mail is genuine, this mail is fraud, etc. Then with this data and output, I will tell the computer, please make a rule how you will detect spam. This is machine learning. I hope you got the idea. Let me just check whether anyone has any question. Okay, this is not really related question anyway. Any suggestion for non-technical background with a current role as quality analyst aspiring any data science role in a few months? Yes, if you're a quality analyst, you have a role in terms of that the people who develop data science products, you have a role to test them. and check whether the products are becoming okay, good or not. So that is a typical role, and I would not say that's a totally a non-technical role, because that's also a technical aspect of product development. So that is ready-made application of your knowledge in your current domain itself, without having to venture out anywhere. Okay. Now, machine learning, there are typically three ways, three types of machine learning. The first type we know as supervised learning. Supervised learning, we discussed one example, like we talked about spam. So in supervised learning, what we do is that we take the data and we give the knowledge about the data to the computer. We say that, for example, I took the mails and I told the computer, this mail is spam, this mail is not spam. So I give him the knowledge. So we have two components. One is the data, and second, when the knowledge which I'm giving him, that is known as the labels. So I take the data and the labels and give it to the computer and tell him, now using this data, you make your algorithm. You learn, and after you have finished learning, then you apply that learning on the fresh set of data which I will give you. This is typically the way supervised learning works. Say, for example, another example could be 1 minute. Let's take that I give him I give a computer information regarding all the prices of houses in a locality, and I tell that, supposing now in this locality a new house has to come up, what should be the price of that? So the machine should be able to check from all the information what it has got and give you a output regarding what the price of the new house should be. So this is typically a supervised learning. Or take a more genuine example from a practically applied example. In Dubai, if you go to Dubai, you will notice that there are a lot of cameras all over Dubai. What these cameras are doing is that it's basically capturing the faces of all the people and trying to determine whether the person is happy or sad. Now, Dubai police feels that if a person is sad, then there's a high chance that the person may create a crime. So they would like to isolate such person. So now, how they would have done it is that they took what you call data regarding lot of people. Some of the data was regarding people who are happy. Some of the data was regarding people who are sad. They put this information into the computer saying that this is the picture of a happy person, this is the picture of a sad person. Then the computer had to make its rule saying that, okay, fine, this is the rule by which I can say that this person is happy, and this is the rule by which I can say that this person is sad. Now, when any person walks in front of a camera, the computer is applying that rule and saying that, okay, this person is most probably happy and this person is most probably sad. So this is a typical example of supervised learning. So in supervised learning, you saw that we are first feeding knowledge into the computer based on which it is able to apply and generate rules. On the other hand, there is unsupervised learning in which we just give the data to the computer, and the computer has to find out what to do with the data. We typically do this when we have to, let's say, make clusters of the data. Supposing I give the data regarding a lot of customers of a retail store to the computer and say, please group these customers into various clusters so that I can apply various different promotion schemes on each individual clusters. So this is a typical example where the computer will be utilizing unsupervised learning. Now, third type of machine learning is known as reinforcement learning. Reinforcement learning is a debatable subject, but nevertheless we can understand it. For example, we have autonomous cars. Now, Elon Musk has developed autonomous car and he tests it in Atlanta and it works perfectly fine. Now, when he gets this car to New Delhi, he has to again reinforce the learning into the car so that the car can now run autonomously in New Delhi, because parameters from Atlanta to New Delhi are going to be totally different or very vastly different, and the car has to learn once again how do I navigate myself around in New Delhi? So this is a typical example of reinforcement learning. Okay, I will just check whether there is any question. Give example to predict cost of property, like flat value is 45 lakhs in the current scenario. What would be the price in 5 to 10 years? This is a very simple problem. We call this problem as regression. So we can take a lot of parameters, and based on that we can do a regression and find out what is going to be the price of a house in the near future. And we can take various parameters like inflation and property value increase rates, etc. And we can do this. This is a very common area of application of data sciences. We will talk about regression very shortly. I'm an undergraduate data science student. Is master in data science required for job? Any degree always helps in terms of getting a better job or doing a better more than a job, doing a better work. Knowledge always helps. So when you have more knowledge, it always helps to do a better activity from whatever job you're doing. How can we enter data science career? I have experience of 11 years. Data science career, you need to find problems in the areas of data sciences. I'm exposing quite a few of them, and you don't need to change careers. You can apply data science in your current career. You already have 11 years of experience. If you look around in your own work area, you will find number of applications of data science you can apply to your own area, and without changing career, you can become a data scientist. Is this only based on past data? No, it can be based on there's something called regression. Regression is based on past data, and typically, see, the thing is, in supervised learning, I definitely require history, because I have to train the computer based on some knowledge, and the knowledge cannot be in future. Knowledge has to come from the past. So you can say that yes, it is based on past data. Please provide me from some link on stock market tool you developed. I will see when I can publish it, so you can get hold of that. Please give examples to predict cost. Oh, I've done that. The question is, which question is this? Anand is not answered. Anand, if you could post your question once again, I will, because I cannot find your question. I'm sorry if I missed it. Okay, let's return back to the presentation. Now, there are two broad categories of algorithms which we apply in machine learning. One algorithm set is known as regression, and one algorithm set is known as classification. So regression algorithms we typically apply for continuous kind of data. Continuous kind of data means, let's say, for example, the gentleman asked, how do I predict the price of a house 5 years from now? So if I have the cost of a house, the price of a house for the last 20 years, then based on that data, I can create a regression model which can say, okay, fine, next year the price will be so much, the next year the price will be so much, and so on. So, for example, the stock market prediction. I collected the stock market data from 1999 onwards till about 2016, and I had so much amount of historical data. Based on that, if I take a particular stock, let's say TCS, and say that from 1999 to 2016, the TCS price has been going like this, the curve has been going up and down this way. So now, what will be the price of the TCS share in 2020? So that is typically one example of a regression model. Now there are various kind of regression models available. The simplest is the linear regression. Then we have logistic regression. Logistic regression is basically utilized for classification. Then we have polynomial regression and step regression, etc. A lot of regressions. You can study this up and you can apply them. The classification problem are basically two types. The basic form of classification problem is binary classification. One example of binary classification we discussed, like spam analysis. So whether the mail is a spam or not a spam is basically a binary decision. So I will do a binary classification whether the mail is spam or not a spam. Or let's say I'm doing a picture analysis which has to take a decision whether the picture is that of a dog or not a dog. So if that is the case, it is a binary classification. But if I have to take the same picture and classify whether it's a dog or a cat or a lion, it becomes multi-class classification. Yeah, now I am doing classification for multiple number of classes. So typically we were discussing about ready-made products like Amazon Deep Lens. Amazon Deep Lens is a device which is fitted to the camera, and this can be utilized for security monitoring, etc., where it can detect objects. So it has got certain capability that it can detect certain number of objects, maybe a flower vase or a glass it can detect. So it will typically do multi-class classification, where it will tell you that this is a glass, or this is a bowl, or this is a chair, or this is a table, this is a person. This is typically multi-class classification. Now we discussed about recommendation system. This is another class of algorithms which you will find very frequently, especially in things like Netflix or Amazon. Netflix was the people who actually started this algorithm, or started this business of recommendation algorithms. Okay. Now you can get very rich libraries for creating any of these systems using these algorithms in R language, Python or Scala or Spark, or even traditional programming languages like Java, etc. There are ready-made platforms available now like AWS or Azure, where you just put the data into AWS and tell him I want to do regression analysis. It will automatically say this is the dependent variable, this is the independent variable, and now should I do the regression? You say yes, and it will create the model and give it to you. So this is all possible in today's world. So there are people who do not want to do programming. There are tools available, but these tools have limitations. You cannot do very high-tech job with these ready-made tools. I will just check back whether we have any more questions and then come back to you the presentation once again. I have 11 years experience in aluminum smelters. My profile is BTech, PGDM. I am stagnant present job and want to change fields and enter data science. Please suggest how to try. No, see, the thing is that uh, 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 I recommend to anyone. You have 11 years of experience in aluminum smelters. You look around your own job in your company or in your what do you call in your engineering field. You will find so many applications of data science. You just look for problems and apply data science. You will become a data scientist. Like I told some time back to someone else as well. But if you want to go from engineering to some other engineering, you can do that as well. But that is, I do not, I'm not the right person to advise regarding that. Kindly suggest some tools which can be used for data analytics. I told you for data analytics, you can use Power BI or Tableau. These are tools which is possible. Can you please upload the presentation in IMT portal? That you will have to discuss with the organizers. I am not the person who can help with this regard. Okay, let's get back. We are almost done. I think I'll skip through this very quickly. Now, the basic steps which we require to create a data product is that we have to gather data, we have to pre-process data, we have to split the data randomly into test, train, and validation groups. You have to create the model, test the model, validate, and then use the model. Now, why I included this slide is because each of these boxes can form a business. I can do a business just for gathering data, or I can do a business just for cleaning data. Okay, or I can do a business just for creating models. So each of these boxes can create a business. So this is why I included this slide, to just give an example of where I will run through very quickly now because we've overshot the time. And this is some new areas. You can look at this: computer vision, natural language processing. By the way, natural language processing is an area which is there since 1960s. The earliest translator which was developed was in 1960s, which could translate between a few languages. And nowadays we have speech to text conversion and text to speech. You have ebooks which can read text for you, etc. Then you are all familiar with Siri, Google Assistant, etc. But these are, I call them new areas because all these technologies are very new and they can be improved and they can be developed much more. And so you have a huge opportunity to explore and do research and come out with better tools for these areas. Lastly, there is something called neural networks. Neural networks are networks which we create, which are supposed to simulate the way the brain works. So there are multiple examples of this, like CNN, RNN, etc. You could explore that. Okay. Lastly, this is a question I've answered while answering some of the questions. Basically, I feel that you require a deep amount of knowledge of statistics to be able to step into data sciences. And you require a good amount of background in mathematics. There are a lot of people who say that this is not essential. However, I have realized that without this knowledge, it is quite difficult to do any reasonable amount of work in data science area. And you need to be able to look for operational issues, because every operational issue can be solved using data science. And if you cannot look for problems, you cannot find solutions. So, and last but not the least, you need to have a lot of patience, because creating models takes a lot of time. A typical example is that when I take when I'm creating a model on a machine with 64 GB RAM, and I say that iterate through my model about 10,000 or 1 lakh number of times, typically it takes the computer around about 7 to 8 hours before the model is generated. So you need to have patience, and then it is not sufficient to create one model. I need to create at least 5-6 different models and then check which model is the one most suitable, and then make a decision, okay, fine, I will utilize this model. So it requires a lot of patience. So with that, I have come to the end of the presentation. I hope you found it useful. I have 10 years experience in C++, C#, SQL developer. How can I learn? Applied? Yeah, you are already a very mature developer. So you can utilize C++, C#, etc. for data science, but it is not recommended because the library set is not so good. You can easily transition to programming language like Python or R, and that will make it much more easy for you to create, to apply data science or create data products. That would be my recommendation. Okay, so that is the end. Madam, if you would like to conclude, I am done. Okay, I thank you all for having participated. So with this, I close my session. Thank you.